Good morning, everyone. Thank you for coming. My name is Ken Haugen. I am a solution architect at Seagate, and I'm here to talk about the transparent cloud tiering service that is part of IBM SpectrumScale and how you can use it to push and pull cloud data in a way that maximizes your high-performance storage. The beauty of it is that it can move the data out of the high-performance storage to cloud storage, which is less expensive, and yet leave the directory listings behind, the metadata, in a way that users don't actually realize anything has happened. The cloud storage can be public cloud or private cloud or some hybrid between the two, depending on your use case and your needs. It automatically picks the data so that once the administrator has set up the policies, things just work without a lot of manual actions, a lot of time taken to make things happen. The other nice thing about it is because transparent cloud tiering sits between SpectrumScale and the cloud storage, it inherits the data management capabilities of both. So, why use it at all? Common estimate is that as much as 80% of what's in primary storage, be it a NAS or a high-performance storage cluster, about 80% of it is stale. Not read, not used, not modified for months. You generally can't just get rid of it because people get upset when their data goes missing. Imagine that. But you don't want it cluttering up your high-performance storage when you need that space for other projects and other uses. So the transparent cloud tiering doesn't delete the files, but it does move them. Gets them off into an archive of some kind. This is different than backing up to tape, because when you back up to tape, depending on your solution, it kind of looks like it's been deleted, and certainly getting access to it can take a while, maybe even requires the user to make a request to an administrator, hey, give me my files back, and they get upset. They may even forget what files they have. They can't remember the exact names. They're just, oh, it was this directory that I used to have. Bring back everything in there. With transparent cloud tiering, it's still all there. The directory listing stays the same. Any metadata they've put with the files stays exactly the same. The content is off in the cold storage, but getting it back, all that has to happen generally, all that has to happen is the users simply read their files. But the effect is the same for the administrator. His capacity in his high-performance storage, his expensive storage, is freed again for the next project. The automation is one of the most valuable features in transparent cloud tiering. Magic happens, and no one even has to wave a hand. You manually set up the policies that decide what happens automatically, but once that is done, transparent cloud tiering just takes over. And they move the files from the fast storage to the cloud storage. So what are the pieces? Well, first of all, you need a SpectrumScale high-performance storage system. The Seagate Cluster Storage G-Series is one example. There are plenty others, because SpectrumScale, of course, is fairly agnostic when it comes to hardware. It's been qualified on a number of platforms, even an open computing platform. The version of SpectrumScale does need to be version 4.2.1 or higher, and new features are added to SpectrumScale, or will be added to SpectrumScale as things go along, that enhance the transparent cloud tiering. You do need a data management license. If you have an advanced server license already, the feature is there. If you are buying a new SpectrumScale system later in the year, data management will probably be a better choice. The G-Series uses Seagate enterprise capacity disks. Naturally, it comes from Seagate, and has InfiniBand, Ethernet, or OmniPath communication interfaces. So we can achieve up to about 112 gigabytes per second per rack. Decent high-performance storage system. The next piece are the transparent cloud tiering nodes, which are separate dual processor servers actually running an instance of SpectrumScale set up to be TCT nodes. There is an IBM questionnaire that helps guide the deployment, so you figure out what you need ahead of time and then get things set up, organized properly, so when you stand it up, it works. I said it was a dual processor server, pretty generic. It does need a communication interface that matches what is on your high-performance storage cluster. I mean, you could go through some kind of gateway, but that's not going to be very efficient. So if you're using InfiniBand or you're using OmniPath, you'll want one of those interfaces in the TCT node. If you're just using Ethernet, great. Have an Ethernet interface in the TCT node. If you're connecting to the cloud then, what interface do you use for that? Well, you use whatever your cloud interface is. Generally, it's going to be some form of Ethernet, and if you're a public cloud, it's probably going to be 1 gigabit or 10 gigabit. If you have a private cloud, you might go as high as 40 gigabit to improve the transfer speeds. Decision's up to you. You can have up to 4 TCT nodes per spectrum scale file system. There's actually a somewhat more complex arrangement where you can have 4 node classes per spectrum scale file system, and then 4 nodes in each of those classes, but that gets a little more complex. We'll just talk about the 4 node case for here. But with 4 nodes, you get reasonable transfer speeds, and you get redundancy in case any one of them goes down for some reason. The service is still there and still running. So the final piece you need is cloud storage to send your data to. Public cloud is one very good choice. Currently, TCT is qualified with, of course, IBM's own soft layer, IBM's own cloud object storage, Amazon S3. Really, the interfaces that it works with are S3 and Swift, but the ones that testing has been done were those 3. The advantage of cloud storage, public cloud storage, is, of course, that it's a pay-as-you-go. You don't have to make a big capital expense outlay at the start. You use as much as necessary whenever it's necessary. And, of course, it's available in more than one location. Although, I want to be clear here, when you put data into the cloud storage with TCT, you can't access it directly from the cloud storage. You only access it through spectrum scale. Won't make much sense otherwise. So, using public cloud storage, use it as a permanent solution or a temporary gap to get you over a period when you don't have enough storage in your own data center, whatever suits your usage model. Private cloud is another way to go. Typically, the private cloud will be a lot faster because it's all within your own network and you don't have to wait for transfers across large distances or the latency involved. If you have enough scale, if you have space in the data center, yes?
Well, just on that point of scale, what is the tipping point for scale?
You'd have to price out the solutions and weigh that against your own capacity. Ours gets interesting when you have 12 nodes, and with 12 nodes, you're right at about 7, 8 petabytes. With ours. With other solutions, for example, there's been a lot of talk at this conference of how the cloud object storage has their own hybrid solution. You can talk to them about what size makes sense and gets economical. Really, it comes down to the economics of it. You'd want to compare the public cloud plan that you get, and then work with your storage provider to figure out, amortized over some number of years, that's the only way to do a fair comparison. Taking into account power and people and everything else, how does it balance out? I've taken a stab at it. It makes sense pretty fast to go private, but you then take on the management burden of doing it. So really, it's up to your own use case. Do you have space in your data center? Are you co-locating? What are the fees to co-locate a new set of equipment, stand to the power? It has to be worked through. That's what people like me do. We'll work with you to do the pros and cons and figure out when it makes sense. But my feeling would be if you want to do something like retrieve terabytes of data within an hour, well, I said retrieve, I should have said recall. Technical term for TCT is recall. If you want to recall terabytes of data within an hour, if you have multiple petabytes, you should probably be thinking about a private cloud. Anyway, the ClusterStor A-Series is one good example of a private cloud. It runs Seagate's own Miro software. This is object software we wrote ourselves. And with the 8 terabyte archive disks, which are SMR, shingle magnetic recording, we hit a very good $1 per terabyte cost point. We have 40 gigabit Ethernet connections to the rack. So getting back to your TCT nodes, you'd probably want to put a 40 gig Ethernet connection on that. And we get 10 gigabytes a second of read or write bandwidth per rack. So again, use when the scale makes sense. And when does the scale make sense? Different for every use case. So you have your TCT nodes in place, you have your spectrum scale, you have your object storage, be it public or cloud. What does the administrator actually have to do? The administrator has to write the policies. The policies govern when data is moved and what data is moved. The terms for the data movement from the high-performance storage to the cloud are pre-migrate and migrate. What's the difference? Pre-migrate copies the files from the high-performance storage to the cloud, leaves the data content in both locations. Why would you do this? So that in the background, you gradually move things over so you're not taking up too much of your bandwidth. If you want to move things fast, it can move things fast. But a pre-migration policy will generally find a window of time when you know your high-performance storage is, well, is high-performance storage ever idle? No, but maybe in less use than in other times. Or it may even look for when the load on the high-performance storage cluster is low. Okay, go ahead and start copying some files. Migration will, when a copy is resident on the cloud, delete the data, leaving behind the metadata, but delete the data from the high-performance storage. So pre-migration gets things ready. Migration actually frees up the capacity for whatever the next project is. So a typical trigger for actually finishing the migration will be things like the capacity on your high-performance storage cluster has fallen below some threshold, or you may just do a hard and fast policy of, hey, if a file isn't touched for 3 months, maybe it's time to just go ahead and finish the migration and free up the space proactively. Policies also govern how the data is recalled from the cloud storage back to the high-performance storage. The most common policy to do this is when a user reads a file that has been migrated, recall it. But a more sophisticated policy might integrate with a job scheduler, where you know some big job is coming up, it's going to need a certain set of files that's defined in the job scheduler. It works with a policy to make sure the files are in place before the job is actually scheduled to run. Up to you. The other thing the administrator has to do is pay some attention to the network. The network's going to be very important here. You communicate with a public cloud, you know how to do that, but of course, you also know you'll have to worry about things like, how do I make sure I don't incur too much communication bandwidth charges? How do I make sure my connection to that public cloud is secure? Within your network, you'll have to worry about things like, do I need to set up a separate network that is just for this? Can I run it over a normal backbone and it just takes up some space on it? These are all things that an administrator will have to figure out. But the key to avoid annoying the users, which of course none of us want to annoy the users, to avoid annoying the users, you really have to make sure that when a fast retrieval is necessary, the network path is there to handle it. What do the users do? They read their files. They don't know anything's happened. That's the key to this. They don't know what you're doing in the background. It's just a service, a storage service, operates the same way it always has. Maybe there's a little more latency when they read a particularly large file, but otherwise, everything is there. They don't know anything has happened. So let's talk about a use case. Imagine you have a private content repository for video or very large images, but these days it's video. And you have your high-performance storage. As the developers create their content, create a frame, finish a project, it gets stored on the high-performance storage for review and editing. This eats up space fast. 4K video, you're talking hundreds of terabytes for even 30 minutes to an hour worth of content. So, great. While the work is going on, the high-performance storage is very much in use. It is touched and updated. New files are added to a project over and over again. Great. Then the project's over. The developers move on to the next project. They can't allow the content to be deleted because maybe it'll be needed again. Right before a show goes to broadcast, oh, we got to fix one thing. Go back in and touch it real fast. Or there's news about one of the stars of a show. Oh, we're going to need a clip. And that needs to be extracted, prepped, and sent off to news organizations. Whatever the reason, old projects do get used from time to time. So you'll need to move them back quickly. And again, we're talking hundreds of terabytes. You can't wait around all day. And the need is unpredictable. You have to respond quickly. Content's got to be recalled fast. So, using the kind of policies we talked about before, TCT can either automatically tier the stuff off to cloud storage, or maybe the administrator will say, oh, I know this project is over, go ahead and start moving it now. And then when it's necessary to be used again, users read the files, everything's there. This is a picture of what this example looks like, where you have your high-performance storage, the Seagate G series, of course. You start with that. For this particular example, I assumed that the high-performance communication interface is just 40 gig Ethernet because people don't generally like to put InfiniBand cards in video editing workstations. But it'll be reasonably fast. So a 40 gig Ethernet connection from the high-performance storage to the TCT nodes, and then another 40 gig connection from the TCT nodes to the cloud storage. Could you reuse the same one? You could, but the two sets of storage are almost certainly going to be on different subnets. It might be more convenient to have a separate path. Really up to you, because the way the TCT node is designed is up to the administrator to figure out. And then I show a A-series cluster with 2 racks, which, as I said, would be about 8-ish petabytes. So if you have more resources, there are, of course, plenty of information on the web. I'm showing Seagate's webpage here for the cluster store systems, where you can find out more details about the G-series or the A-series. The current G-series system is the G300, G300N. The current A-series is the A200. IBM has a specific wiki page for spectrum scale transparent cloud tiering with lots of information about the, how it works and so forth. That link is there. And then, of course, there's the overall spectrum scale webpage with plenty of information about the spectrum scale product. And contacts. I've shown 2 of us here from Seagate. Chris Gerard is the G-series product manager, and I'm a solution architect. Not a good idea. I'm a solution architect. And then Jeff Season, who's here in the room with us, is an excellent resource from IBM for anything you need to know about spectrum scale. That is the end of the presentation. Do you have any further questions? I should have repeated the first question for everyone. I'll repeat this one. What is this really championing the use of spectrum scale as a gateway? And it all depends. If your active file set is really huge, you might as well have a large spectrum scale system to hold everything. If your active file set at any one time is fairly small and you can afford to move things back and forth pretty quickly, sure, it could be a relatively thin gateway to an object storage system. It's a hard question to answer. It would depend on the use case, but spectrum scale is a really rich storage product with all kinds of capabilities. So if you want those capabilities and still have the cost of object storage behind it, that is what we're really saying here. If you can design a primary file system that is large enough to hold your active content. Any other questions? Okay. Thank you all, everyone, for waking up this morning and attending the session.